Welcome back to the OBIS Controlled Vocabulary series. In this video, we will follow the P01 decision tree for a few example biological measurements. If you are not familiar with this tree, please see the first video in this series. The first example we will look at is simple, the length of an animal. Beginning at the start of our decision tree, the first question is, of course, which identifier are we looking for? And we are looking for measurement type ID, not measurement value or measurement unit. The next question is, what type of measurement do we have? And the options are physical, chemical, or biological. This measurement pertains to that of an animal, so we will take the biological branch. The first action we see is to navigate to the CDataNet facet search, which we have open here already. The next question is, what is the object of interest that is being measured, and is there a subcomponent? The object of interest is an animal, and in this case, there is no subcomponent. So between the two, we will select the one on the left for biological entity specified elsewhere. So on the CDataNet facet search, we will type in biological entity specified elsewhere. Now we have applied this filter to our search. You can see that we have 104 results, and already the results are populated with different measurements. We see that the action is to search for biological entity specified elsewhere, which we have already done, and then from the biological entity section, we must select biological entity specified elsewhere as well. Note that this step is not necessarily required, but let's take a look at how we would apply the filter by scrolling down to the biological entity specified elsewhere section. Here you can see that there are several options, and you can also toggle this section to expand it by clicking the drop-down arrow. This reveals all the hidden options available in the section, and this can be useful to do during your search, but keep in mind that it may reveal a very long list of results. So by mousing over each of the terms, we can see the full name, and right away we see that most of these options have to do with subcomponents for a biological entity specified elsewhere. So if we want to apply the first filter, which is just biological entity specified elsewhere with no subcomponent, this will narrow our search results by excluding all measurements related to subcomponents. So we can click to apply this filter, and we see that our results have gone down to 92. And as a reminder, this step may not always be necessary, but it's good to know that it's an option available to you. The next question is, what is the measurement property? And a related question you should think about is it a statistically derived parameter? Is it a mean, max, min, so on? If our measurement was statistically derived, you can also look in either the SO7 or SO6 collection for examples of terms that either are statistically derived or are not. The next action in the decision tree is to search for a measurement or select it from the measurement property section. Our measurement was length, and we can see that it is already here. So what happens if we click length? Now we can see there are three results: the length of biological entity specified elsewhere, the length maximum, and the length minimum. The next action was to look in the search results for P01 code that best matches our data. We can also use the questions below to help narrow the search. These questions have to do with the matrix and the methods. However, our measurement is rather simple, as it is only the length of the biological entity. And so we will click this concept ID, which brings us to the NERC vocabulary server entry for this measurement type. We should always check that the title and the definition match our measurement type. In this case, the definition is the mean length of specimens of a biological object identified elsewhere in the data or metadata in the sample or observation. This may refer to a single individual if the count is 1. So this matches our measurement type for length of an animal. So what we will do is we will copy the URI here into the measurement type ID field. Before we move on, I would just like to point out that when we applied the filter for length, you can see there are only 3 length measurements. However, if you were interested in another type of length, such as fork length, you would have to use different keywords. So I have removed the length filter, and instead, if you want fork length, you can type that into the free search field. And that would give you fork length of the biological entity specified elsewhere. You can do this with other length keywords, or simply search generally for length. We'll see an example of broadening our search later in this video. Before we move on, let's look at a quick example for cases where we're interested in the length of a subcomponent. For example, the length of a sea star arm. To do that, we'll have to remove filters for fork length. We'll also have to remove this filter for biological entity specified elsewhere, because if you recall, this filter excluded all measurements related to subcomponents. So we are going back to this step in our decision tree, where instead of no subcomponent, we're looking for measurements with a subcomponent. And of course, the measurement property was length. So right away, we can see a list of 12 results, some of which have subcomponents. Because the list is so short, we can easily filter through ourselves to identify this measurement, length of biological entity specified elsewhere, subcomponent, starfish arm. You can see that there are a number of other subcomponents that you may be interested in. For now, let's obtain the URI for this length measurement. So of course, the definition says the arm length of a starfish, also known as sea stars, identified elsewhere in the metadata. That's perfect. You can go ahead and copy this URI and paste it into the measurement type ID field for records with this measurement type. For the next example, we will look at something a little more complicated, the count of birds observed while at sea. So of course, this is a biological measurement. We have already navigated to the CDataNet facet search. What is the object of interest being measured? Is there a subcomponent? There is not a subcomponent, but the object of interest is birds. So this would be the biological entity specified elsewhere. So like before, we will type that into the free search box. And we will select it from the biological entity section to ensure the search results filter out any subcomponents. The next question is, of course, what is a measurement property and is it statistically derived? So the measurement property is count. If we search for count, this gives us 6 results. Notice that if we were to select count from the measurement property section, this would only give us one search result, the count of colonial individuals per colony of biological entities specified elsewhere. This is an example of overfiltering, where sometimes when the filters are applied, it narrows down the results too far. To fix this, we will simply remove the filter for count, and now we've returned to our search results with 6 results. This overfiltering happens because measurement types are sometimes assigned to a specific element within the semantic model. So for this example, count, only one measurement type is specific to count, whereas the others are still related to count, but in different ways. This is something you should be aware of when searching for P01 codes. If search results become too narrow, you may need to remove a filter and read through a wider list of results. Now, returning back to our example, the next action says to look in the results to find a code that best matches our data. The first result is the count of colonial individuals per colony of the biological entity specified elsewhere. However, our measurement is not measuring colonial individuals per colony. The second one is count in an assayed sample of biological entity specified elsewhere. This one seems general enough that it could match our data. But let's look at the other search results. The third one is count of breeding pairs. And we know we're not looking at breeding pairs, so moving on. The next two are statistically derived, with mean seasonal count of the biological entity and a maximum seasonal count. And then finally, we have a midwinter count occurring in January of the biological entity specified elsewhere. So the measurement that seems closest to our measurement of interest seems to be the second one. So let's take a closer look. We're looking at the definition for this P01 code. It's the number of individuals of a biological object, in this case birds, in the sample or observation. So although it says count in an assayed sample, which might be somewhat confusing, the definition tells us that it's simply the number of individuals in an observation. Therefore, we can use the URI for this P01 code in our measurement type ID field. Let's look at one more example, one where considering the matrix or methods is also important. For the last example, we will look for a P01 code for the wet weight biomass of cyanobacteria measured in micrograms per liter. So beginning our search, again, the first question is what is the object of interest? With cyanobacteria, we're not looking at a subcomponent, so we will again type in the biological entity specified elsewhere. We will also select it from the biological entities section, so we exclude all of the measurements related to subcomponents. What is the measurement property? Well, it's the biomass. Is it statistically derived? No. So we are going to search for our measurement. Let's type in biomass. We still have 14 results. So we could look through here, but let's think about the next question. What is the matrix? So as we already saw, most of the time the matrix isn't as relevant for biological measurements. When they are relevant, there are typically only 3 matrices that are most relevant for OBIS when it comes to biological data. That is the water body, the bed, and the sediment. If you're interested, you can look in the S26 and S21 collections for more details and examples about matrices. In our case, we're looking at the biomass of cyanobacteria in micrograms per liter. So this means that our measurement was taken from the water body. So from matrices, we're going to go ahead and select water body. So what we have just done is this action, considering if our biological measurement has a matrix element. In this case, it did. The next question to consider is, were any methods used to obtain the measurement? Well, we don't have any information about how the biomass was obtained, so we can skip this question. And then finally, what's the measurement matrix relationship? The action here is, if your measurement occurred within a matrix, consider the relationship between the two. Well, our measurement is the biomass per liter. So looking under this section, measurement matrix relationship, there are 3 options: per unit volume of the, per unit length sampled of the, and per unit of sampling time in the. So in this case, we want per unit volume because our biomass measurement is in micrograms per liter. So we can go ahead and select that. Now we only have 5 search results. The first one is biomass as carbon of biological entity specified elsewhere per unit volume of the water body by flow cytometry. Well, that doesn't fit our measurement. What about the second one? Wet weight biomass of biological entity specified elsewhere per unit volume of the water body. This one sounds closest to our measurement of the wet weight biomass of cyanobacteria in micrograms per liter. But let's look at the others just to be sure. The next one is the ash-free dry weight. Well, already we know that this is for dry weight biomass, and we're interested in wet weight biomass. And same thing with the fourth measurement, dry weight biomass of the biological entity specified elsewhere per unit volume of the water body. And the last one is biomass as carbon of biological entity specified elsewhere per unit volume of the water body by computation. The only one of these 5 measurements that fits our measurement type is the second one. So let's go ahead and click on the concept ID for that. So look at the definition. It's the mass as caught of an identified biological object described elsewhere in the metadata, occurring in a given volume of any body of salt or fresh water. This definition captures our measurement type quite well, and so we will copy this URI and place it in the measurement type ID field. For more measurement type examples relating to physical and chemical measurements, please see their respective videos.